Welcome back to Refreshing Careers. Today we're going to start linear programming. This chapter comes under Operations Research, which is a subject in MBA. Now let's start with the introduction of the same. In this video, in whatever videos we're going to make, we'll be mainly focusing on the problems rather than on the theory. So I'll be making only the initial videos for theory, and wherever in the problem there is a need for theory, I'll be adding theory over there. But I'm going to focus mainly on questions, because when you solve questions related to operations research, it is little tough. It's not very tough, but it becomes tough because it's little confusing. So that's the aim of making these videos regarding operations research, just to make sure that the problems, the practical part of it is made easy. Theories can be even explained by teachers, we also can read, it's easy to understand, but main focus of mine will be on the practical portion of it. This video, however, will be covering theory, because little knowledge of what is linear programming is obviously needed so that you can solve the problems. Only after knowing certain theory only we can go to practical. So the important theory part will be covered by me now. Okay. Now since you're studying linear programming, we should be knowing who is the father of linear programming. The father of linear programming is Leonid Kantorovich. Okay, he realized that optimization problems could be solved using the same mathematical principles. Okay, he realized, like with his experience, he realized that we can use the same principles. He had certain principles. Here principles refers to the principles of linear programming. He felt that by using this linear programming, we can solve a lot of optimization problems. So that's why he came up with this particular subject of linear programming. He did a lot of research over this, and then it was developed. And one of the important things that we need to know is resources are limited. Resources are not unlimited. They have an end. Water is not unlimited. There would be an end. Okay, LP is linear programming. Linear programming, it helps organizations to allocate these resources which are limited. Now all these optimization problems, why are we trying to optimize? We are trying to optimize everything because the resources are not unlimited. If the resources are unlimited, there's no many things to worry about. But since all the resources are limited, we need to plan efficiently so that we're not wasting the resources, and at the same time we're making completely utilizing those resources and making the maximum profit out of it at the least cost. That's why we need to optimize it, and this linear programming is just a tool that is helping us to optimize. Okay, it will help us to allocate these resources. For example, let's say I'm a doll manufacturer. Okay, I manufacture teddy bears, and I manufacture and some other, panda. Let us say panda. I manufacture only these two things. Okay, and the cost of this is, for manufacturing one teddy, okay, this is for one teddy, maybe some 20 rupees. So panda, it is 30 rupees. And the price at which I'll be selling this will be, let's say, 40. This also I'm selling at 40. Profit would be 40 minus 20, that is 20. Here it is 40 minus 30, 10. So what's happening over here? Here we are producing two types of dolls. One is teddy, one is panda. The cost of production of panda is 30. So producing panda is costly. Producing teddy is cheaper when compared to panda. Okay, but the price at which it is sold is 40. Because of which the profit that I get from teddy is more. And what's the reason? The reason is cost is lesser over here. So that becomes a reason for me to get a higher profit. Okay, in the market I'm selling it at the same price because I know that if I sell panda for let's say 50 rupee or 60 rupee, no one is ready to buy, or the market is very less. But if I sell it at 40, I am able to sell lot of pandas. So I feel that I cannot increase the price and it remains 40. So in these these are optimization problems. Here we will be trying two things. Okay, mainly all our questions or sums would be related to cost minimization and profit maximization. Cost minimization and profit maximization. This would be our focus. The main focus would be on this. Let me first talk about cost minimization. Now let me say that when we saw this and we understood that cost of producing panda is more. So now I'm going to buy a machine. I'll buy another machine that is going to reduce the cost of production of panda. Earlier I was using hand to make these pandas. Now I'll decide to use a machine and the cost comes to 10 rupee per panda. So for each panda it is 10 rupee and the price at which I'm selling is same like before, 40. So the profit is 30. How did this profit increase? How the profit increased from 10 to 30? It increased because I reduced the cost. So that is nothing but cost minimization. You are minimizing the cost so that your profit maximizes. Okay, this is just a basic example that I gave so that you understand why are we minimizing cost and why are you maximizing profit. These are the two ways in which you can increase your profit itself. If you minimize your cost also, you are going to increase your profit. If you increase the profit also, you are going to increase the profit. Okay, now let's go to the next thing. Now, when can it be applied? When can you apply it? It can be applied under two conditions. Now, every time I cannot use linear programming. It's a tool. If you have to use a tool, there has to be some conditions, right? Like for example, let me say if I have to use laptop. If I have to use laptop, what is the condition for it? There should be, the battery has to be charged. Okay, there has to be charge in the laptop. Only then laptop is going to work. I need to have some internet connection so that I could be able to use Google and all. There should be some operating software. So these are the conditions for me to use a laptop. Similarly, for using a tool like linear programming, there are some conditions. Okay, only if these conditions are fulfilled, only then you can use it. Otherwise, it will be of no use. Like if you want to study using a laptop, certain prior conditions, as I told you, have to be fulfilled. If those conditions are not fulfilled, then you cannot study with it, right? So similarly, linear programming also can be applied under two conditions. The first condition is courses of action should be available. Okay, course of action available are known. Okay, the course of action, first thing, it should be available. It should not be like a dead end. Okay, like if there is one course of action, then what is the confusion? You have no other choice. You have to choose this itself, right? If the course of action is only one, then there will be no confusion at all. You have to go for this. There is so many problems. Problem of optimization arises. Problem of optimization arises only when there are at least two courses of action. So minimum there has to be two courses of action. Only then a problem arises. Confusion happens only when there are two things you can choose from. If I have only one chocolate, there is no confusion. I'm going to eat that chocolate. But if I'm having two chocolates in front of me, say Dairy Milk and Kit Kat, then I start thinking which one should I eat first. So the confusion always arises when there is more than one option. Okay. So the first condition says that the course of action available are known to the organization. Whatever course of action are available, various course of action available has to be known by the organization. That is the first condition. The next condition for applying linear programming is the objectives and the constraints have to be quantified. The objectives and constraints have to be quantified. You should be able to quantify everything. See, this we are solving linear programming. Since we are solving linear programming, we have to have numericals. Only then we can solve. If I say my weight is more, if I say my weight is more, what will you understand? Can you solve such a thing? It's very, qualitative in nature. My statement is very it's qualitative in nature. But if I say my weight is 45 kg, if I say my weight is 55 kg, then what happens? Then you get a number, and that number helps you to solve the problem. Even if I tell you my weight is either 50 or 40, like if I am adding numericals, if I'm adding numericals, then it becomes easy. So there has to be numericals involved. You cannot just say statements that that cannot be converted into numericals. I cannot say that I am more heavy, because from this you're not able to understand anything. But if I say that Alina is 30 kgs and I'm I'm not 20 kgs more heavier, then I know that my weight is 50 kg. So this what is happening here? We are just quantifying. We are quantifying the objectives or constraints, or we're just quantifying the statement. What are objectives? What are constraints would be the next question. We'll be covering it later, but it's easier to understand actually. Objective, let me say here in the doll kit. What's my objective? My objective was to reduce the cost of production of the panda. I wanted to reduce the cost of production of panda, so that was my objective. What is my constraint? My constraint would be that the machine which I want is available only in Russia, and at present in Russia war is happening and I'm not able to get the machine. So that could be a constraint. But this this constraint cannot be quantified. So such constraints cannot be taken. I just give an example of constraint. Others, you can say that I do not have enough funds for the same. Okay, or maybe after 30 days I'll be receiving some amount, and later I'll be doing. So the lot of problems that come in my way for reducing this cost from 30 to 10, those things would be called as constraints. They would be called as constraints. And the reduction, the cost reduction which is happening here is my objective. My objective is to reduce the cost of panda. My objective is to reduce the cost of panda. That is my objective. So that becomes objective. Constraint is anything that is stopping me from reaching my goal or objective. Okay. Now these are the conditions. Okay, so these two conditions are important so that you can use the tool of linear programming. Next. Now what are the assumptions? Assumptions of linear programming. Whenever you are solving problems related to linear programming, some things are assumed. Some things are assumed, and these assumptions should be kept in mind. Okay, these assumptions you have to keep in mind. Otherwise, you would be wondering why they are saying like this, why they are saying like that, because all those things come under assumptions. There are certain assumptions of linear programming, and every problem that we do, so to keep these assumptions in mind. The first assumption is that of linearity. Linearity is what? It means, see, there are variables in any equation. Let's say there's an equation x plus y is equal to z. There exists a linear relationship. There exists a linear relationship between the variables. Or if I write it as, x plus 3, y plus 8, z is equal to 50. What's happening here? This is also a linear equation. First thing is, this is an equation. Here what's happening? There exists a linear relationship there exists a linear relationship between the variables. What are the variables here? X is a variable, y is a variable, z is a variable, and there exists a linear relationship between variables. Okay, that is, there exists a linear relationship between the input and the output of production. You can say this is the input and this is the output. Okay, all these three, x, y, z, are the inputs of production. Number of units of x that is used to produce these 50 units of output is how much? Let's say it is $50. Okay, to make it clearer, let's say to produce $50, I need to use this input x, input y, and input z. I need to use 1 unit of x, I need to use 3 units of y, and I need to use 8 units of z, and then I get $50. So I need to find out x, y, z. So this is a linear relationship that exists between the input and the output of production. Next is continuity. See, continuity means all the variables that is x, y, and z should have a numerical value. We should be able to express it in terms of numbers. Should have a numerical value. X, y, and z should have a numerical value, because only then it becomes measurable. Okay, to make it measurable, x, y, z should have numerical value. That's all the variables should have numerical value. The next thing is independence and additivity. Additivity means you should be able to add more numericals. Like if I have to add another unit, say if I have to add t, another input, I should be able to add it. So that is additivity. That is, I should be able to add more variables. I should be able to add more variables. Independence. Independence is simple. Independence is all variables have to be independent of each other. Okay, x, y, z are not dependent on each other. All of them are independent of each other. Variables have to be independent of each other. Okay, variables and the numerical values should not be dependent on any other variable. That's what this means. Next is proportionality. What is proportionality? Proportionality is there is a proportional relationship among the variables. That is, there is a proportional relationship among the variables, that is x, y, z. So proportional relationship among the variables, and the proportionality between the variables remains the same while finding out the solution of a problem. For example, if we know that x is to y is 3 is to 4, and we know that x is to y is to z is equal to 3 is to 4 is to 6. Okay, if we know such things, we know the proportion that's existing. The proportionality between the variables, that is x, y, and z, remains the same. It remains the same while finding out the solution of the problem. That means whenever I find out the value of x, y, z, the proportion is going to be this itself. There won't be any change in the proportion. For example, let's say our x is 9. Let's say x is 9, x is equal to 9, then y is equal to 12, and z is equal to 18. Now let's check the proportion. Let's say that we found out the values of x, y, z, and this is the value that we get. Now let's find the proportion of it. The proportion will be 9 is to 12 is to 18. I'm finding the proportion of x is to y is to z. Yeah, everything goes to table of 3. 3 3s are 9, 3 4s are 12, 3 6 are 18. So what's the proportion? 3 is to 4 is to 6 is the proportion. This is the meaning of proportionality. That is, the proportion of the this variables or the inputs in this case will be the same. The proportion is going to be the same. Next is constant price. As per the assumption, the price of input is going to remain constant, and so is the price of output. The price of input is going to be constant, and the price of output is going to be constant. regardless of the quantity sold and purchased. That is, see, if I'm selling teddy at rupees 40, one teddy if I'm selling at 40 rupees, this particular price is going to be constant. The price of 40 rupees for selling one teddy is going to be constant. The price of the input and the price of output, that will not change. Okay, that is not going to change. That is what this assumption says. The price will not change, or whether it is of input or whether it is of output. Linear programming can be defined as a tool. It can be defined as a tool or technique of optimizing. That is, how can you optimize? Optimizing is, you can either maximize or you can minimize. Okay, so linear programming is a tool for optimizing. That is, for maximizing or minimizing a linear function. So there is basically a linear function which you need to maximize or minimize for different constraints expressed as linear equations. See, why is again and again linear equations is coming? It's like everything is going to be numerically expressed and everything is going to be expressed in the form of linear equations only. Otherwise this cannot be solved, because we have certain assumptions, right, due to which it will be linear equations. Everything we should be able to numerically express, whether it is constraint, whether it is our objective, whatever it is, whatever our goal is, it has to be expressed numerically. Whatever problems or constraints are there just stopping us from reaching to that goal, that also needs to be expressed numerically. Basically everything has to be expressed numerically, and it has to be we should be able to express in the form of linear equations. This we'll understand better when we start solving questions. Till then, just understand it roughly. Okay, that's just a tool that is used for optimizing. That is either maximizing or minimizing a decision. Okay, which has got different constraints. Okay, either you're maximizing a particular thing or minimizing something. That will be a linear function, because that decision would be expressed in a form of linear function. Decision, you can say that it's a goal. You can call this as a goal. So you're either maximizing or minimizing something, and that would be your goal for different constraints, and that goal will have different constraints, and this goal also is expressed as linear function, and constraint also is expressed as linear equation. Now let's understand some important terms. These 4 terms are very important for us to understand so that we can solve problems, because every time the word would be again and again used and it would be a little confusing. I'm not going to take exact examples like how it's going to be in problems. I want to make it little more simple. Let's again go to doll production. Okay, let's go to doll production. So I am confused how many teddies I should produce, and how many pandas I should produce. Okay, I'm very confused how many teddies I should produce and how many pandas I should produce so that I get maximum profit. I'm very confused. So in this case, what is my objective function? My objective function is to maximize. Okay, my objective function is to maximize. Sorry for the handwriting. Is to maximize profit. Okay, here my objective is what? To maximize profit. I want to know how many teddies should I produce and how many pandas I should produce, so that I will be able to maximize my profit. So my aim is what? My goal is that I have to maximize profit, or I can even this will be expressed numerically. Okay, right now I'm not expressing it numerically, just to make people understand. I'll be expressing it numerically in the coming video. Okay, in this one let's understand it through simple examples. Okay, so here decision variable will be what? Decision variable will be how many teddies I should produce and how many pandas I should produce. Let's say this is represented by T and this is represented by P. How many T's I should produce and how many P's I should produce. This is a question, or that's called a decision variable. That is, you are solving this entire problem to find out how many teddies you have to produce or how many pandas they should produce. So this will be represented by certain alphabets or alphanumerical values. You can represent it as x1, x2, as per your wish. So it will be represented through some variables. Those are called as decision variables. Okay, so you are actually solving the entire sum to find out these decision variables. So this T and this P would be your decision variables, and your objective would be to maximize profit. That's your goal. Now what are the constraints? Constraints would be, now to maximize profit, I can produce, the constraint would be such that, let us say that there is some input to produce both teddies and pandas. I need some input. Let's say I need cotton. Okay, I need cotton, and I can maximum arrange only 100 units of cotton. Okay, which has to be shared. I can produce only 100 units of cotton, and this 100 units has to be divided among teddies and peddies. The constraint is this 100 units becomes a constraint, because there's only 100 units and this 100 units has to be distributed effectively. Such things could be called as constraints. Okay, these are called as constraints. Anything that is stopping you, or it is restraining you from achieving your goal, that would be a constraint. If this cotton was unlimited, then that should have not been a constraint at all. If I require some 200 units of cotton for teddy, I will get 200 units. If I need 500 units of cotton for pandas, I'll get 500 units. But then when they put the constraints that I will be getting only 100 units, I'm going to get only 100 units of cotton, now it is a problem. Now I know that I can't get more than 100, and this 100 units has to be divided efficiently between these two, so that I can achieve my goal of, or my objective of, maximizing my profit. So that is called as constraint. Anything that is restraining you or stopping you from doing something, from achieving your goal, is constraint. Non-negativity variable. This is very simple. That is, your T and your P, okay, will never be negative. Okay, will never be negative. Your T and P can be 0. Your T can be 0. Your P can be 0. It can be more than 0, but it is never going to be negative. That is why it's called as non-negativity condition. So this non-negativity condition applies on the decision variable. Non-negativity condition applies on the decision variable, that is T and P. So non-negative condition means that the decision variables, in this case T and P, can never be negative. It can be 0, or it can be 1, 2, or any other numerical, any positive integer, but it cannot be anything that is negative. Okay, hope everything is clear. Please do like and subscribe the video. In the next video, I'll be coming up with problems related to linear programming, and let's understand linear programming better by solving it, rather than by just seeing theory, because when we actually start solving the questions, we'll be understanding it much better. Please do like and subscribe. Thank you so much.